Third question, M is an element that belongs to the second period in the periodic table. It forms a covalent molecule MCl3 which has a dipole moment. The group of the periodic table to which M belongs is. Right, when we look at the molecular formula, we can see that the valency of this is 3 here. So that means it belongs to either the 13th group or the 15th group, because when we look at the common electronic configuration, it will be S2P1 for group 13, S2P3 for group 15. So S has 2 electrons, P has only 1 electron. Here P has 3 electrons, 2 electrons, 1 here, 2 here, 1, 2, 3. Now if we look at the number of electrons in the 13th group, it has 3. Now the 15th group has 5. Because of the unpaired electrons 3 here, it can form 3 covalent bonds. So if we draw the molecule, let's say since it belongs to the second period, second period, then the second period elements are lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So the group 13 element will be boron, 15 element will be nitrogen. So if boron is our compound, its geometry will be trigonal planar. And when we mark the dipole moment, each bond has a dipole moment to the direction of the chlorine. Since all these dipole moments are identical, they cancels off. Therefore, there will be no dipole moment. The dipole moment will be 0. So it will be a non-polar molecule. Non-polar. Now when we consider NCl3, it will be a pyramidal molecule. It has a lone pair here. When we mark the dipole moments, nitrogen withdraws electrons, therefore chlorine to nitrogen, because nitrogen is more electronegative. This lone pair has a small dipole moment there. So the resultant dipole moment will be from the chlorine side to the lone pair side. So it has a dipole moment, so this will be a polar molecule. So since they say the MCl3 which has a dipole moment, so our compound is this one. Therefore the element M belongs to the 15th group. The answer is 4th one.